Okay, this is day 34, and we're going to jump right ahead through all this stuff, which of course I hope you're working on these exercises at home on your own. You don't have to worry about math drill because we will have calculators, although it certainly helps to know your math facts. So we're going to jump to the math windows, which is what? Page 6 of 11 on lesson 34, the math windows, which we like to start on first. And we got this first one here. 80 girls and boys plan to go on a movie. That's 80 altogether. That means there is a ratio of 6 girls to 2 boys. How many girls are there? Okay, so a ratio of 6 to 2 is the same as a ratio of 3 to 1, right? Because if you divide 6 and by 2 and the 2 by 2, you get a ratio of 3 to 1, meaning there's more girls than boys. There's 3 times as many girls as boys, right? So I'll say there's 3 girls for every 1 boy, right? Now, there's a way you can solve this using an equation, right? But again, a lot of you guys get all kind of nervous about solving things with equations, trying to remember things. Think of it just common sense. There's 80 together, all together. And there's 3 times as many boys as girls. If you said there were 10 boys, that would make 30 girls. 3 times as many, right? But altogether, that's 40. And we want, how many altogether? I forget. 60. No, 80. We want twice as many, right? So why not use twice this then? If there's 20 boys, then there would be 60 girls. 3 times as many. 60 and 20 is 80. There it is. That's the right answer. What was the question again? How many girls are there? 60 girls. There's 60 girls. That's doing it by just called trial and error. You think of the problem and you just try to find numbers that would work. And sometimes it's pretty fast. They give you easy numbers like this. You can find the answer pretty quickly. If you were trying to solve it mathematically, you would say the ratio from girls to boys is 3 to 1, right? But since they gave us number 80 for the total boys and girls, I'm going to put that on the bottom here, and I'm going to set up a ratio. The total, if the ratio of girls to boys is 3 to 1, that means there's 3 girls out of 4 boys and girls, because this is the total. This is the total boys and girls. So this is the total in the ratio. 3 and 1 is 4. Out of 4 kids, 3 are girls. Now, how do you solve this? Well, it's like an equation. A ratio is like an equation. You can multiply by 4 on this side and by 80 on this side to clear the 80. The 80 would disappear. So what you end up doing is it ends up being cross multiplying 3 times 80 equals 4 times x. To solve for x, what do? You divide by 4. And if you divide this side by 4 to get 1x, you divide this side by 4. So if you put this in your calculator, 3 times 80 divided by 4, it'll also come out to be x equals 60. Okay, so number 2, what percent of 55 is 34? So remember, percent is what part. It tells you a part. It's like a fraction. So what part of 55 is 34? So percents show a part. So for instance, 50% is equal to 1/2, which is equal to 0.5, which is the same as 0.50, 0.50. So a percent is very much like a decimal. 0.50 is 50%. But you would have to move the decimal point 2 places because this is really 50 hundredths. And percent is how many hundredths? 50 hundredths. So always remember, when you change a decimal to percent, you have to move the decimal point 2 places. 25%, that's equal to 1/4, which is equal to 0.25. And again, you can see you move the decimal point 2 places to get 25. 75% would be 3/4 or 0.75. But we're doing 34. What part of 55 is 34? So we take 34, put it on the top of a fraction, and 55 on the bottom. 34 55ths. That is a fraction, but it can also be changed to a decimal just by dividing. So I got my calculator here. I'll use my phone this time. Okay, I got my calculator. Yeah. This is what I want, right? So I want 34. Well, let me clear this. That's 34 divided by 55. Gives me 0.6181. It keeps going on and on. That's equal to 0.618. But again, I move the decimal point 2 places and I get 61.8, which rounds up to 62%. Okay? What is the area of the circle below? Okay, so area of this circle. This is a circle. This little line from the middle to the end is called the radius of a circle. If you extended that line all the way across, that would be the diameter, and it's 2 of the radiuses. So they even give you a formula here. Area is equal to pi times the radius squared. Okay, what is this little symbol? I said pi, but what is pi? Pi is actually a number. They said use 3.14, but it really goes on and on. 3.141598. It just goes on and on and on. What is that number? Well, what happens if you have a circle and you take the diameter, the length of cross, and you take that and you laid it on the outside of the circle, if you could bend it like if it was a string, and you start at a point and you put the diameter on the circle, and then you took another diameter and put it on the circle, and another diameter. You would need 3 of those diameters to go all the way around, but you wouldn't quite make it all the way around. You need a little bit more. This is the number of how many diameters it takes to go all the way around the circle. 3.14. It doesn't matter how big the circle is. It's always that number, 3.14. That's called a constant. And in this case, we call it pi. So the formula is saying to get the area, which is how much you cover this whole circle, is you take the radius, you square it, which of course means radius times the radius times itself, and then you multiply it times pi. So in this case, we would have 3.14. That's what they're using as an approximation of pi, times, what is it? I can't see it that well. And 8, yeah, it's times 8. Times 8 times 8. You have to square it, meaning you multiply it times itself. Okay, 3.14 times 8 times 8. Let's see, we're going to clear it. Okay. I'm going to go this way. I don't care. Okay. 3.14. That's not good, is it, hey? This is plus 3 point. Where's the point? I'm using a bad phone here. Okay, 3.14 times 8 times 8 equals 200.96, or basically 201. Are any of my answers near that? Let's see. Here it is, 200.96, C. Now that was for finding the area. Looks like the same diagram over here, right? But now we have to find the circumference. Although, you know, in the problem it says area, but we already did that. That should say circumference. Circumference is how far around a circle. How far is it all the way around that line? If you were measuring a big circle and you wanted to measure how far it was around, you do the circumference. Okay, area problems. The area problem we did before. Area, you might be figuring out the area of something if you wanted to cover a floor or cover something that's a circle. You want to cover the whole thing. So that's area. Circumference is used maybe if you're figuring out buying fencing and you want to go around the outside. That's circumference. When the shape is like a square or a rectangle, we say perimeter. But with circles, we use the word circumference. So the formula for circumference is what I talked about before, the diameter times pi. Here they're saying 2 pi r because there's 2r is 2 radiuses. If you put the r and the 2 together, you get 2 radiuses. That's the diameter. The formula most people know is pi times the diameter, but 2 pi r is the same thing because it's 2 radiuses. So in this case, you would have 2 times 3.14 times 8. Okay, let's see what I get for that. I'm a little slow on using my calculator because I don't use calculators that much. Okay, 2 times 3.14 times 8 equals 5,024. Now I didn't put my decimal point with the 3.14, so it's 50.24. That would be the circumference. So here on lesson 34, the lesson today, day 34, the lesson today is on the coordinate plane, in which we do coordinate geometry, linear algebra, a lot of uses for the coordinate plane. And a plane is basically a flat surface. It is a plane. And here they use a grid. I advise you to read through these next 2 pages. It does a good explanation of how to plot points on a coordinate plane. And a plane has both length and width to it, as opposed to a line, which is just a single line. A plane is both across and up and down. So you can plot points in a plane if you use 2 numbers to plot the points, one going sideways. In this case, they're using the x-axis here that plots left to right. We also have plot up and down with the y-axis that plots up and down. So you can plot any point on this plane by using 2 numbers, one that shows the x and one that shows the y. So here's an example here. They're plotting the point 3, 5. The x they plot first, which is the right to left, left to right, going sideways. And as you can see, 3, 5 would be 3 over and 5 up. Y is the 5. That's 3, 5. Now, they go on to explain different things about the coordinate plane here. One being, let's see, here's another point they plotted right here. This would be -3. So they use negatives too when you go this side of the origin. The origin is the middle where the 2 axes cross. That's 0, 0. If you go to the left here, you're going negative. This would be -4, and then you go down to -8. So the point is written as a parentheses, -4, -8. Again, the x is first, the y is second. Okay? Over here you see what's called quadrants. If you divide the coordinate plane into 4 quarters, they call this the first quarter. And in the first quarter, the x is positive and the y is positive. In the second quadrant, the x goes this way, so it's negative, but the y is still positive. In the third quadrant, the x is negative and the y is negative. So coordinates here would be both negative numbers. And in the fourth quadrant, the y is positive again now, but the x is positive, but the y is now negative, so it's positive, negative. Those are your 4 quadrants, okay? Moving on. They give some examples. Example 1, find the ordered pairs for the points A, B, C, and D. So here's A. It's in the first quadrant. So you do the x first. 4 over, 2 up, 4 comma 2. The B would be 5 up. No, we do the x first, not the y. Negative 3x, maybe 5.5 y. The C would be over here, 4x, negative 4y. And the D would be negative 3x, negative 3y. And this just goes on to explain them, but it's all pretty easy stuff. Oh, here's another page. Example 2. Plot the following points. And it asks you to plot those. 1 comma 2, 4 comma negative 1, negative 3 comma negative 2, 0 comma negative 3. Okay, and then if you look to the side here, you can see them plotted. A was 1 comma 2, 1 over, 2 up. Now that looks like 1 comma 3 to me. Okay. B is 4 comma negative 1. So A, they actually plotted wrong. If you look closely, it's 1, 2, 3 up. But they put 1 comma 2. They wanted the 2 up. It should have been there. B is 4 comma negative 1. Is that what we got? See, their things are not matching up with the graph paper. That's one of their problems, is they're not matching up with the graph paper. Okay. Anyway, you get the idea of how they plot them. Notice this one, D was 0 comma 3. So you stay on the axis. That's 0. Negative 3 would be down there somewhere. Okay. Okay, so now we're going to do some coordinate plane practice. Okay, coordinate line practice. 4 quadrant ordered pairs. Okay, remember this one is your first quadrant, all positive, positive x, positive y. Second quadrant, negative x, positive y. Third quadrant, negative x, negative y. And fourth quadrant, positive x, negative y. And it says on our exercise down here, indicate which point is located at each ordered pair. 2 comma 8. So it's positive x. We do the x first, remember. 2 comma 8. Well, it's off the thing here. Let me go up to 8. Way up there. 2 comma 8 would be P. Negative 5 comma negative 5. Negative 5, negative 5. N. These you should have all done before me, but if you get the idea, you just do them before me. 4, and then you can check if you want, if you think you might have it wrong. 4, negative 7, you go down. F. The biggest mistake people typically make is they forget which goes first. X comes before Y in the alphabet, so do your X and then your Y. 4, negative 1. 4, negative 1. U. 7 comma 3. 7, I want to go up 3. 1, 2, 3. T. Negative 3 comma 5. Negative 3, 5. Whoop. Oh, up. Negative 3, 5 is positive. M. Negative 6, negative 4. Negative 6, negative 4. L. That's pretty easy stuff, huh? They do this even in second grade, or they used to. Negative 3, negative 4. Negative 3, negative 4. Q. Okay, write the ordered pair. This time we got to look at the letter and write the ordered pair. S. S, 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 S. Where's the S? Did I miss it? Here it is. So it's negative 7x, negative 8y. So you put a parentheses, negative 7 comma negative 8, I think I said, right? V. V, 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 V. That's why. There's V. Uh-oh, X. There is no X. That's because it's 0 there. 6. 0 comma 6. parentheses 0, comma 6. X 4, negative 5, 4, comma negative 5. J 2, comma negative 3. Okay, I'm not going to go on with this because I don't want to waste time on my video camera here trying to do all these. Those are too easy. Plot the following points. This time you have to plot them. So they want W at negative 2, comma negative 6. Negative 2, negative 6 would be right there, right next to the E. And that was what? W. C, or is it a G? C, I guess. Negative 5, comma 4. Negative 5, but 4 you go up. And that would be C. Anyway, you try these out, okay? Plot all those points. Very simple stuff to do. This is probably one of the simplest lessons we're going to be doing is this with the plotting points. Of course, this is not all there is to it. We're going to find out why we are plotting points, what these points are used for. They can be have very many uses for plotting equations and lines and curves and all kinds of things. Okay, coordinate plane practice continued. Okay, on exercise A, write the ordered pair for each point. I think you know how to do these. Point A, you do the x first, negative 4, comma 5. Make sure you put the parentheses first when you do this, okay? Parentheses, negative 4, comma 5. You can do all these for practice. If you think you need it, you might think, oh, I know this stuff from before. I know it now. It's so simple. I'm just going to skip it. Don't be afraid to skip something you're really sure about, okay? Because that will just give you more time to work on other things, okay? Well, let's go down to the bottom here, see if that's a little harder. This is still simple. Plot the following points. You plot those points. Number 10, plot the following points. And again, it's pretty much the same thing. Now let's go down to number 11. Okay, now we're seeing something like a line. That's the first thing they're doing, lines, where that's what we're going to be working a lot with, is drawing lines on a coordinate plane. Okay, on the coordinate grid below, a line passes through points A and B. A, by the way, is what? Negative 2, comma 2. B is 0, comma negative 2. But the question is, which of the following ordered pairs also lies on the line? So how are you going to figure out if those points lie on the line? Well, you just look at each of the answers. A is 1, comma 0. 1, and no y, 0. That's over there. That's not on the line. 1, comma negative 1. 1, negative 1. Nope, that's not on the line. Let me point with my pen. 0, comma negative 1. 0x, negative 1y. Almost, not quite. How about negative 1, comma 0? Negative 1 and 0y is right there. That's on the line. D would be the right answer. How about number 12? Two of the corners of the triangle are located at 3, negative 3, and 2, comma 3. What is the location of the third corner as shown in the diagram below? Well, we got to figure out which one's the third corner. So we're going to look at the ones they said. 3, negative 3. 3, negative 3. That's that point there, right? 2, comma 3 would be 2, 3. That one there. So we want to know this point. So you do the x first. Negative 3, negative 2. Where is it? Oh, A is the right answer. Negative 3, negative 2 is the other point. Okay, simple enough. This was a very easy lesson, but we're going to be using this coordinate plane to solve other kinds of problems. Now you might wonder, what kind of problems have these? Well, you'll see there are relationships in which it can be plotted on coordinate planes as lines or other curves. There are very complex things in science which use complex curves to solve real-life problems, real-world problems that we have. Anyway, on to lesson 35, or day 35 in your books.